inverse of a matrix. We had discussed about matrices in our previous slides, but now we're going to talk about inverse of a matrix. So how can we find out the inverse? Listen to me. This is a matrix of order, yes, 2 by 2, as there are 2 rows and 2 columns, 2 by 2 order. To find out the inverse, you have to firstly find out the minors of matrix and then cofactors. What are minors? As you know, general form is A11, A12, A21, A22. These are the elements of matrices. This shows first row, first column. The number at position first row, first column. This is first row, second column. This is second row, first column. This is at second row, second column. Okay? Now, minor. First row, first column. If you have to find out the minor, then what you have to do is first row, first column. You have to hide it. What you get? 3. This is your minor. M12. Minor of first row, second column. First row, second column is 1. Minor of second row, first column is 5. And minor of second row, second column is 2. Okay? Now, turn is to find out the cofactors. For cofactors denoted by C or A, Cij is minus 1 raised to power I plus j Mij. I is row, j is column. So, if you substitute, listen to me, you sum up this. 1 and 1 is 2. If you put it here, minus 1 raised to power 2. Minus 1 raised to power even is 1. So, at even position, when sum is even, the minors and cofactors are the same. But for minors at odd position, cofactors has the sign opposite to them. Means plus have minus, minus have plus. Means cofactors at C11, C12, C21, C22. So cofactor of this is, as you know, this is even. So this and this remains same, as these are even, but these are odd. So this becomes minus 1, minus 5. Got it? These are the cofactors. Now we are talking about adjoint. To find out, in order to find out the inverse, you have to find out the adjoint. And you know what? Adjoint is a matrix which is the transpose of cofactors. Now the question which strikes in our mind is, what is the transpose of any matrix? So let us take an example. This is your matrix, and you have to find, if you have to find out the transpose of this matrix, then you have to interchange the rows and columns. Means rows becomes columns and columns becomes rows. Then you said that this is the transpose. Means this is first row, 2, 5. Now it becomes in transpose a column, 2, 5. This is second row, this becomes second column. I hope you get it. So adjoint is the transpose of cofactors. Cofactors are 3, minus 1, minus 5, 2. The transpose is it. Transpose of it is, this is row, this becomes column, this is row, this becomes column. This is the adjoint. Okay, clear? So this is adjoint. Now you have to find out the determinant. What? Determinant. Determinant means multiply this, 3 2s are 6 minus 5 1s are 5. So determinant becomes 1. Okay. As determinant is not 0, that is, it is non-singular matrix. If determinant is 0, then we cannot able to find out the inverse. As for singular matrix, if we have to find out the inverse, then in A inverse is 1 upon A determinant adjointing. And you know, if denominator becomes 0, it becomes indeterminate form. So how can we find out the inverse of any matrix whose determinant, that is denominator 0? So that's why it is essential, it needs to be non-singular matrix for the existence of inverse. Exactly. So A inverse, the formula is this. Now substitute all these values which you have found out previously. A determinant is 1. Adjoint A is this. So our inverse becomes just adjoint A as determinant is 1. Okay, I hope you understand. But this is the inverse of 2 by 2 matrix. Now we will proceed it with our next example, which is 3 by 3 matrix. Firstly, you have to confirm that whether the matrix is singular or non-singular. So how can we confirm or make sure that a matrix is that or not? You have to find out the determinant. The question is this: a 3 by 3 matrix, 3 by 3 order, as these are here, there are 3 rows and 3 columns. So this is a square matrix, as number of rows and columns are equal, of order 3 by 3. Now turn is to find out the determinant. Determinant, how can you find out the determinant? Listen to me. This is A11, A12, A21. A11 at even place, sum is even, sum is even. This is odd, so you have to take minus with that. Means you have to take 1, and now hide first row, first column. What do you get? What do you get? 0, minus 1, 1, 0. Okay? Now, this is at odd place, so minus 3. Hide first row, second column. What do you get? Minus 3, 2, minus 1, 0. Okay? This is at even place, so the sign remain as it is. Now hide first row, third column. What do you get? Minus 3, 0, 2, 1. Okay? Now you have to find out the determinant of each and every part of 2 by 2 matrix. So this becomes 0. What we do? 0 zeros are minus 1 ones are. So this becomes 1 minus 3. This becomes 0 plus 2 minus 2. This becomes minus 3. So 1 minus 6 plus 6, that is 1. As determinant is not 0, so this is a non-singular matrix. Then we can find out the inverse of this. So how can we proceed with that? First step is to find out the minors. M11, M12, M13, M21, M22, M23, M31, M32, M33. Now listen, I told you about the minors. You have to hide that position at which we have to find out the minor. So at 1, 1. So hide 1, 1. Now you have to find out the determinant of this part. And determinant of this part is what? 1. M12. Hide this. M12. You have to find out the determinant of this part. This is 2. M13. Hide this part and you get minus 3. And so on. Similarly, you have to find out the minors of each and every term. For 2, 1, hide 2 at the elements at 2 and 1. Then 0 plus 2. 2, 2, 0 plus 4. 2, 3, 1 minus 6, that is minus 5. 3, 1 minus 3. 3, 2 minus 1 minus 6, that is minus 7. 3, 3. 3 3s are 9. Okay. Now for cofactors, you have to just write down all the minors. 1, 2, minus 3, 2, 4, minus 5, minus 3, minus 7, 9. And now at subsequent position which are at odd places, that means a square, you have to change the sign. Minus becomes plus and plus becomes minus. Alright, as you see, this is 1, 1. So this is at even place. This is 1, 3, 3 and 1, 4. So this is at even place. This at even place, this at even place, this at even place. So these 4 elements are at odd places. So you have to change the sign of that. Okay. So cofactors become this. And now the turn is for finding out the adjoint. For adjoint, as you all know, adjoint of any matrix is what? Cofactors having transpose. A matrix with the transpose of cofactors. Cofactors are this. So taking transpose of this is first row. So this becomes first column, second row becomes second column, third row becomes third column. This is a matrix with adjoint, and now the final thing is you have to find out the A inverse, which is 1 upon A determinant adjoint A. Now substitute all these values. What is our A determinant? What was that? You have to substitute here adjoint A here, and you got the answer. I hope you understand how can we find out the adjoint, how can we find out the minus, determinant, inverse. In this video, we are talking about inverse. Now, we shall be proceeded with our next topic in our next video. If you have any doubt, you can subscribe us and discuss your doubts or share your doubts. We can definitely solve your problem. Okay? Thank you. Keep learning.